The second part to the first lesson, we're going to focus on the graphs. So the ones that are in this lesson I've produced for you, but we'll also take some time and we'll go back to those polynomials that we looked at their equations, and we'll take some time and put them into your calculator so that you can always get a picture of the polynomial, and that'll help you whenever we get to the characteristics. Okay, but right now what you should know is whether, if I give you an equation, whether or not it fits into this family of being a polynomial function. The three different types of polynomials, again, are linear, quadratic, and cubic. And next lesson, we'll kind of put some things together and say, well, what does a linear equation look like with its graph? What does the quadratic equation look like with its graph? And we'll start to pair them together with their characteristics. Okay, so what we want to talk about in this one is, how do I know from the graph that I have a polynomial function? And that's the last three bullet points, those last two bullet points in your notes when you go back to that page, and it's the graph must be continuous and the graph cannot oscillate. So when you have a picture of a polynomial, we want to think about, or a non-polynomial, we're thinking to ourselves, does it oscillate and is it continuous? If it doesn't oscillate and it is continuous, then I have a polynomial function. Okay, so let me go back actually to these keep in mind that's in your book. It has the picture of these three functions that we're going to study, a linear, quadratic, cubic. A constant is a type of linear, so those are together. So I'm going to highlight just the general shape of them so that you get an idea of what it looks like. So a linear function has the word line in it, so you're going to have a line on your paper. Right, so whenever you graph those points, it would have formed all along a line, and that was that first one that you looked at. A quadratic looks like a bowl, right? It has that cupped look, or it has a downward. So we say it's either an upward quadratic or a downward quadratic, but it has, it's called a concavity if you want the sciencey term of it, right? And then cubics, they have a very specific look. So they're like taking a linear function and putting a bend to it, right? So if you think that the red was a linear, well, I'll take that and make it have a little bit of a bend in the middle or a curve in the middle, and then you get a cubic. So they can go either direction. So you can take a climbing, an upward linear function, which is a positive one, and if you put that bend to it, then you get that cubic. So those are the three types. So graphically, you might be able to just say, I recognize it as being a quadratic. I know it's a polynomial. That's ideally what you want to do. But let's talk about it in terms of those two bullet points. Do we have an oscillation, or do we have a continuous, non-continuous? All right, so for part A, there's one that should now look familiar to you. Okay, so it's not oscillating, and what I mean by oscillating is an oscillating function does that. So what you can relate it to is like a spring. A spring that goes up and down is oscillating, and it's oscillating between 2 points. It's going up and down. So if it oscillates, it's not a polynomial. And then you also want a polynomial, it has to be continuous. So what do I mean by continuous? So if you take your pencil, and we read functions like we read a book, we go from left to right. So if I put my pencil coming in from the left, and I start to trace the function, if I get to the very end of it, and I haven't lifted my pencil, then it's a continuous function. Now these functions do go on forever, but in our world we have to stop them. So what you can do is just think about, right, it has to end is it continuous? Can I put my pencil down? So since this is continuous, I never had to lift my pencil as I traced the whole thing. It's continuous and it doesn't oscillate. So this one is a polynomial. Part B, if I go from the left to the right, I'm going to come in here, I'm going to go very far left, I'm going to keep on tracing it, and then I get to a certain point, and yeah, I know it keeps on going down forever, but on my paper it's ended. So if I need to get over and continue on with my tracing, I have to lift my pencil and come up here to continue. So this is a break. This makes it not continuous. Since it's not continuous, it's not a polynomial. Anything that has a break in it. Okay, there's two more. So part C, think about, is it continuous? Does it oscillate? It's not oscillating because it's not going up and down, up and down, up and down. So we're going to think about, is it continuous? So I would take my pen, start at the left, the farthest left I can go. I'm going to start to trace it. And I get to the end, although I know it keeps on going forever, but on the paper I never lifted my pencil. So this is continuous, and it doesn't oscillate, so this is a polynomial. And in fact, we can start to put a name to these now. This is a cubic. It has a line that has that bend to it. That first one, this is a quadratic. And the last one, so this one, when I go from left to right, all right, I got all the way to the end and I never had to lift my pencil, so it is continuous, but as I did that, it was oscillating. So this is an oscillating function. It is continuous, but this part, that oscillation, makes it not a polynomial. Okay, so what we want to do now is there's actually some problems in the book that you can try real quick. On page 157, real quick, there's number 1 that has 3 graphs on it, and it says determine which graphs represent polynomial functions and of what types. So now start to see if you can put a name to it. If it's a polynomial, what type is it? Linear, quadratic, or cubic? So I'll pause here, let you do those. I'll come back, put a name to them, and then we'll practice in our calculators. Okay, so out of the 3, A, B, and C, C is the one that is not a polynomial. So you see that there's that break, right? If I trace it, I have to lift my pencil to get over to the other side. These are called branches, but we can see there's that gap, and that makes it not continuous. A and B are both polynomials. See if you got the name right. The part A is the cubic. It's the line that has the bend to it, and part B is linear. So they're putting them there, kind of makes a good comparison for you, how they're related. Okay, so what we want to do now is, let's go back and take a couple of those polynomials from the first lesson, and let's just practice graphing them real quick. Okay, so if I take, I'll write one up here that you have on your paper already. If I take f of x equals x squared plus 3x plus 2, let's go over really quickly how to put that in your calculator. So you're going to turn it on, you're going to hit the y equals screen, clear out anything that's in there, and we're going to put that into our y1. So remember the X is underneath that mode button. So I'll hit X, and then the squared button is in that first column. It's above the one called log. You'll see a little X squared. That'll give you the exponent of squared, plus 3x plus 2. When I get it written in there, I'm going to hit graph, and you should see the picture of the polynomial. And what you should see is something that looks like that. It does go on forever, but again, our screen's only a finite, has finite dimensions, but that's what it would look like. So take a minute and you can practice a couple of those, and even try to graph some of those non-polynomials just to verify that you have something that either breaks or maybe it's an oscillating function. So that's this lesson, focusing on the pictures, the graphs of those polynomials.